Welcome to Platform 2024. Thank you for joining our session on the HyperCore Data Protection Suite and how you can maximize your investment. I'm Chris Schultz, Director of Product Marketing with Scale Computing, and today I'm joined by Mitch Etchison, Senior Product Manager on Scale Computing HyperCore. Over the next half hour, we'll define data protection, look at what goes into protecting data and the threats, the cost of data breaches, strategies, and then Mitch will dive into data protection with Scale Computing HyperCore. So what is data protection? Simply put, data protection is the process of protecting sensitive information from damage, loss, or corruption. As the amount of data being created and stored has increased at an unprecedented rate, making data protection a priority is crucial for continuing business operations. First, we need to acknowledge the significance of data in today's business landscape. Data fuels decision-making, innovation, and competitiveness. However, with great data comes great responsibility. Business operations depend on data, and even a short period of downtime or a small amount of data loss can have major consequences on a business. What goes into protecting data? Data protection has three key focuses: protecting data from malicious or accidental damage, quickly restoring data in the event of damage or loss, and ensuring that data is accessible to those who need it and not to anyone else. At its core, data protection encompasses a variety of practices, policies, and measures designed to shield data, ensuring that it remains secure, reliable, and available when needed. It's a dynamic and comprehensive approach to managing information securely, balancing the need for accessibility with the imperative of safeguarding it against a wide range of threats. It's a continuous effort that requires collaboration, adaptability, and a deep understanding of the evolving security landscape, such as what we are protecting data from. I think everyone's heard this before. It's not a matter of if, but when a company will face a data breach. The adversaries we face today are persistent, and they're adapting and refining their techniques at an unprecedented pace. In fact, 55% of data breaches are attributed to organized criminal groups. These groups operate as sophisticated enterprises, collaborating and sharing resources to maximize their impact. And they often specialize in specific types of attacks, contributing to a diverse and complex threat landscape. Cybercriminals increasingly rely on ransomware attacks, encrypting valuable data and demanding a ransom for its release. These attacks can cripple organizations. The proliferation of IoT devices introduces new vulnerabilities, as these devices often lack robust security measures. So exploiting these weaknesses can lead to unauthorized access, data breaches, or even control over physical systems. Phishing remains a prevalent and continually evolving threat. Attackers use sophisticated social engineering tactics to trick individuals into divulging sensitive information through phone, text, email, and social media scams by pretending to be a trusted source. Zero-day exploits capitalize on vulnerabilities in software or hardware that are not yet known to the vendor or public. Cybercriminals leverage these exploits to launch targeted attacks before patches or updates are available. They also continually develop new and sophisticated malware variants to evade traditional security measures. Polymorphic malware in particular can change its code structure to avoid detection. State-sponsored cyber espionage is rising, with nation-states engaging in sophisticated attacks to gain strategic advantages, steal intellectual property, or disrupt critical infrastructure. And of course, there's always the possibility of a simple case of human error. Understanding the nuances of these threats informs the development of proactive data protection strategies that can adapt to the evolving tactics employed. A data breach is not merely a technical hiccup. It has far-reaching consequences. The immediate financial impact of a data breach includes expenses related to incident response, forensic investigations, and remediation efforts. Beyond immediate expenses, there are indirect financial consequences, such as the loss of business opportunities, declines in stock value, and increased costs associated with reputational damage, which is one of the most significant consequences of a data breach. Customers, clients, and partners may lose faith in an organization's ability to protect their sensitive information, leading to a damaged reputation that can take years to rebuild. The negative publicity resulting from a data breach can overshadow an organization's positive contributions and achievements. A data breach may trigger investigations by regulatory authorities, resulting in fines and legal consequences for noncompliance. And remediation efforts can lead to operational disruptions, including system downtime and business interruptions, which can have cascading effects on productivity and customer service. So what can you do about it? Data protection strategies include people, process, and technologies like these. Through data classification, organizations can identify and label sensitive information, such as personally identifiable information, financial data, or intellectual property. Implement granular access controls and encryption, prioritize efforts, and allocate resources to protect the most critical information. Regular audits identify vulnerabilities and weaknesses in existing data protection measures to help organizations stay ahead of evolving threats. They ensure compliance with industry regulations and internal policies. The insights gained from audits enable organizations to continually improve their data protection strategies. Encrypting data ensures that the information remains unreadable, even if unauthorized access occurs without the appropriate decryption key, which is crucial for protecting data at rest and in transit. And access controls limit access to sensitive data, ensuring that only authorized individuals or systems can interact with the information, which reduces the risk of data breaches and unauthorized modifications. Continuous monitoring involves real-time tracking of network activity and user behavior to detect and respond to security incidents promptly. Monitoring tools generate automated alerts for security incidents, allowing security teams to respond swiftly to potential threats. At a minimum, backups ensure data resilience by providing a secondary copy that can be restored in the event of data loss due to accidental deletion, hardware failure, or cyber attacks. Rapid recovery from backups minimizes downtime, allowing organizations to resume operations swiftly after a disruptive event. And regularly testing backups ensures their integrity and effectiveness and validates their ability to recover data in various scenarios. An incident response plan is a structured approach to addressing and managing the aftermath of a security incident. It outlines the steps for preparing an organization to respond effectively to a data breach, including defined roles, responsibilities, and communication protocols. Clearly defined processes for detecting and analyzing security incidents help organizations promptly identify the nature and scope of a breach for swift containment and eradication of the threat. Post-incident analysis identifies areas for improvement, contributing to continuous enhancement of the incident response strategy. Security integrations seamlessly incorporate various security tools and technologies to create a comprehensive defense. Incorporating any or all of these strategies into a holistic data protection framework empowers organizations to navigate the evolving threat landscape with resilience and effectiveness. Collectively, these measures contribute to creating a robust defense against potential data breaches and unauthorized access. Advancements in technology are, of course, a boon when it comes to data protection. So Mitch will now explore how cutting-edge scale computing HyperCore can be harnessed to enhance data protection while mitigating associated risks. Go ahead, Mitch.
Thank you, Chris, for that excellent review of data protection. I will now explain how industry-standard data protection strategies can be implemented with scale computing platform. As many of you know, the scale computing platform is actually comprised of several products in our portfolio, namely HyperCore and Fleet Manager. Both HyperCore and Fleet Manager provide security features and the ability to implement best-in-class security and data protection strategies. And when combined, they allow for full end-to-end protection. One of the most important aspects of end-to-end data protection is encryption. Over the last few years, we've seen a large increase in the number of customers that are requiring data at rest encryption. This is largely driven due to regulatory compliance as well as requirements from cybersecurity insurance providers. HyperCore streamlines the deployment of in-guest tools for data at rest encryption with our VTPM technology. In 2023, we launched Virtual Trusted Platform Module support. A VTPM is an emulated hardware device that manages cryptographic operations of a virtual machine. It can provide for things like managing keys, providing device authentication, and, in the case of physical machines, prevent hardware tampering. VTPM support streamlines the use of in-guest tools like BitLocker and Lux because it allows users to hold their encryption keys in the VTPM itself, which means enabling encryption with a tool like BitLocker is just a few clicks. While data encryption is key to safeguarding data, as Chris has already explained, controlling who has access to such data is also incredibly critical. As such, HyperCore and Fleet Manager both allow users to implement zero trust policies by limiting system access to just the actions that employees need. First, HyperCore itself has role-based access control that allows you to limit user roles and functionality to the following role types: admin, read only, backup controls only, cluster settings only, the ability to create and edit VMs, the ability to delete VMs, and cluster shutdown. Similarly, Fleet Manager also has its own set of roles, primarily the ability to manage organizational users, the ability to view clusters, the ability to actually control and add and remove clusters from Fleet Manager, as well as the ability to view VMs and full admin access. While role-based access control is incredibly crucial, particularly if using local accounts in HyperCore, HyperCore also facilitates the implementation of single sign-on. We support OpenID Connect, which is an identity layer based on OAuth 2.0 that allows clients to identify users based on an authentication server of a customer's choice. Typically, in the case of HyperCore, ADFS or Entra ID. SSO also allows for customers to implement multi-factor authentication for HyperCore clusters because you can simply require MFA for your authentication provider of choice. For example, we even have customers using tools like Duo to require MFA for logging in via Entra ID as the authentication provider for their HyperCore clusters. Access control is important, but it is also crucial that you implement robust backup and DR strategies. First, Scale Computing has our own built-in data protection suite, which makes it easy to implement backup and DR without additional licensing. The core of our data protection suite is snapshotting. Our snapshots provide point-in-time recovery by instantly capturing the entire VM disk contents and configuration at the time the snapshot is taken. These snapshots are immutable, meaning that the VM itself cannot edit the contents. Snapshots can also easily be cloned and powered on in seconds to provide for instantaneous recovery or a recovery of specific information in a VM snapshot. Snapshots capture any in-flight I/O to the virtual disk and make sure it is briefly quiesced at the precise moment that snapshot is taken. Over 5,000 VMs can be available for each virtual machine. And again, they can be used to easily recover individual files. Additionally, we also have the ability to schedule automated snapshot taking, in addition to manually taking snapshots. Scheduling is important to mean you are routinely capturing your VM data at point in time, but then also can be used with our built-in replication technology, where without any additional licensing, you can replicate HyperCore snapshots to a secondary cluster offsite for DR. Again, snapshots are immutable, which means they are integral to your data protection strategy. This means that snapshots cannot be altered or deleted by their VM in any way. Immutable snapshots change your posture against ransomware and malware because they are fundamentally resistant to these types of attacks. And if you are in a situation where you are impacted by something like ransomware, you can simply roll back to a snapshot prior to the infection. In addition to our own built-in backup and DR technology, we also support third parties. Almost any third-party backup solution can be used to back up HyperCore VMs by deploying in-guest agents. However, we also have several options for agentless integrations, namely with Acronis and Storeware. An agentless integration allows for you to deploy a virtual appliance on the scale production cluster itself, so that way the third-party backup software is aware of the VMs and can take backups of the VMs without deploying those in-guest agents. In addition, Acronis specifically allows for instantaneous VM recovery with their Convert to VM feature. Backup and DR is super important, but so is continuous monitoring. And this is arguably where we've made the biggest engineering investment over the last few quarters, and that is Fleet Manager, our multi-clustering cluster management and monitoring tool. We saw that customers needed better monitoring for fleet, so we built the ability to manage an entire fleet of several to thousands of clusters at a quick glance. We provide a single pane of glass to look at the health of clusters and make sure that your data is running and being protected. What's more, we recently expanded our monitoring capabilities by introducing a VM and conditions lists. This includes info on VMs in one place to provide a cloud-like monitoring experience. While Fleet Manager is primarily a tool for monitoring, it also allows for another additional security benefit: the elimination of needing to deploy VPNs at remote networks. We have a feature in Fleet Manager called Secure Link. Secure Link allows for streamlined, secure remote access to individual VMs, which eliminates the need for VPNs at remote sites. Removing the need for VPNs also minimizes your network attack surface at remote locations. While a lot of these great security features are built in, we have several security-related integrations that make it easy to continue to implement data protection strategies with your scale computing platform. First, AI Edge Labs is an AI-powered real-time cybersecurity solution that we have a partner relationship with that is purpose-built for edge and IoT infrastructure. This is a really powerful protection tool. Similarly, WinMagic can be used via their guest agent to encrypt workloads running on HyperCore. WinMagic encryption keys and services are centrally stored and managed, making ongoing maintenance a breeze. Acronis, while traditionally seen of as mainly a backup offering, also provides its own set of cyber protection strategies. They've recently expanded their portfolio to include more protection features outside of traditional backup, mainly in the area of enhanced ransomware and malware protection. Finally, we also have an integration with RackTalk Systems' Brickstore security platform. This allows users to stop malware at the storage processor and includes features such as real-time threat detection, behavioral analytics and machine learning, automated incident response, and faster time to value for security tool implementations. Finally, a customer like Kitsalis First Nation exemplifies how you can implement data protection strategies on HyperCore. They experienced a flood and needed to replace all of their on-premises infrastructure quickly and implement availability and disaster recovery. Their support team was able to replace their legacy infrastructure across the 5 sites that are running on-premises compute, and as a result, radically improved their uptime and implemented a true DR strategy. Since this implementation, they've saved on resources and cut down at least 15% of the time that they used to require to manage on-premises infrastructure. And now they have a simplified and highly affordable IT infrastructure with improved performance, security, and data protection. Thank you for joining our session on the HyperCore Data Protection Suite and how you can maximize your investment. We hope this helped you get a better understanding of data protection and how to implement protection strategies on a scale computing platform. Thank you.